Okay, so to show that f of x is approaching the limit L, we need to show as x is approaching x naught, we need to show that the gap between f of x and L can get as small as we choose it, if x is kept close enough to x naught. So we basically need to say, if we want to, like, let's say an error rate of the limit, basically, how far we want f of x to be from the limit. Let's say we want it to be 1. We're okay with it being 1 distance away from the limit, or okay with it being 2, or maybe we need it to be super close, so we need the degree of error to be like this. We need to show that we can get as small as we want. The difference between f of x and L can be as small as we want for a given, if x is kept close enough. So if we were to say we want to get this error rate, well, then x will have to be kept within, let's say, 2 spaces of x naught. Otherwise, we won't get this limit. We won't be within this error rate of the limit. And the way we show that is through this right here. We would say 0 is less than the absolute value of x minus x naught is less than delta. Let me see. I don't know if that's a delta. It's something like that. Which leads to absolute value of f of x minus L less than epsilon. Epsilon. How does it say epsilon? Something like that. I'm gonna draw like this. That's how I'm gonna draw epsilon. Okay, basically what this is saying that delta is a given distance that x has to stay within x naught in order for f of x to be within a certain distance of L, or within a certain quote unquote error. Epsilon is that distance. Epsilon is that distance. Epsilon will be greater than f of x minus L, which will be that the error, or how close we are, the gap between f of x and L. And we can use this to show that, and this is basically saying that as we get closer and closer to x naught, we'll get closer and closer to f of x to L. F of x will get closer to L by showing that we can make the gap as small as we want for we can make the gap between f of x and L as small as we want. And we can, given if x is kept within the certain range. If we could show that, then we could show that f of x does approach the limit. I mean, does approach a certain value, aka the limit of that function. So that's what this is saying. This is saying that for any f of x, this is saying that for any distance of x to x naught, we can get closer and closer. We can get f of x closer and closer to L, or make the gap between f of x and L as small as we want, if x is kept within a certain distance of x naught. So if x gets closer and closer to x naught, or the certain distance of x naught, f of x can approach L. F of x can approach L if x naught, x's get closer and closer to x naught. That's what this is saying. So this is the formal definition of a limit. This is saying that as x naught gets closer and closer, the distance between x and x naught gets closer, f of x gets closer to L. Okay, we're going to see examples. I'm going to show you examples. Don't worry, okay. How to find the limit, to prove the limit. So it's cool.